Welcome to another mini lecture on pre-calculus. Topic today is translating the graph of an exponential function. So here we are given y equal to 4 to the power of x. That's the blue curve that is drawn. And we want to translate it for it to become the graph of y equal to 4 to the power of x minus 2 quantity minus 1. So what you're supposed to do there is to take this tool and click it on this spot and drag it to where you think it should go. Let's review to see what is involved here. So the important numbers here, of course, is this minus 2 that you see here, and of course this minus 1. What roles do they play? We have gone through the issue of translation of function a few lectures back. If you remember that, when you replace x by something like x minus 2, the graph of the function is going to move in which direction? Do you remember that? This x minus 2 means we are going to go 2 to right. Okay, x minus any number, we are going to go that number to right. And if it goes x plus some number, we go that number to left. How about this other number, minus 1 here? What role does that one play? This is how much you're going to drag the function down. So it's going to be 1 unit down. Okay. So in this case, we are having a double translation, one horizontal, one vertical. In this situation, it doesn't make a difference which one you do first, which one you do second. It's all the same. So you have to take this point, use this tool, drag this thing 2 to the right and 1 down, and then you'll be all done. As a matter of review, let's just go ahead and write down the general formula. If I have y equal to f of x, that would be my original, like this blue function that is drawn here. If you go ahead and talk about f of x minus c, and then for example minus d, what does this mean? It means c to the right and then d down. Let's write it in numbers so it's a little bit easier to say f of x minus 2 and then minus 1. This means 2 to the right, or right by 2, and down by 1. What are other combinations? Let's write the examples. If I had y is equal to f of x plus 3 and then say minus 4, what does that mean? It means left by 3, so 3 to left. X plus 3 means 3 to the left, and minus 4 means it's going to go 4 down. If I had y is equal to f of x minus 2, say plus 5, what does that mean? It means 2 to the right and then 5 up. Then one more example, y is equal to f of x, say, what else do we have here? Minus, and then say plus 3, and then say plus 7. What does this mean? This means 3 to the left and then 7 up. We gave a short description of how to think about this thing so that we don't rely on so much memorization, and the actions in x and the y direction are the same. And I encourage you to go back to that lecture to see what we said. So uh, if you're comfortable with what we have said so far, and it's fine, you can just stay with that. We said a higher level understanding of this thing that avoids so much memorization and has a foundation that can be applied elsewhere is to put the modifier next to the quantity that is modified. So what does this mean? So for example here, f of x minus 2 minus 1, this 2 affects horizontal movement, so 2 to the right. This y affects vertical movement, so it's best to be written next to the variable that's responsible for that. So another way of looking this problem is to take this thing and write it like this. Take the minus 1 to the other side, so it becomes y plus 1, and now is equal to f of x minus 2. Now the modifier and the quantity that is modified are next to each other. 2 is next to x and 1 right next to y. This the movement that it causes is the opposite of the number that you see here. So x minus 2, it means 2 to the right. Okay, same thing here now. Here you see plus 1, you go in the opposite direction, so you're going to go 1 down. So now we are treating x and y the same way, and there would not be any confusion. Why is it that the x behaves in some way and y behaves in some other way? If you have these numbers on the right, that confusion, you are going to see it, and then the issue is actually going to get worse later on when we come to trigonometry. There are going to be 4 of these actions, not just 2. And trying to memorize is going to be a little bit of a hard task. So if you can, try to understand what was mentioned here. Let me try one more time. So for example, this case, what do you think we should do? So that the x and y treated the same way and we don't need 2 separate rules to memorize. This minus 4 is a modifier for y. Its place should be right next to that. So we take it to the other side, or if you wish, add a 4 to both sides. It becomes y plus 4 is equal to f of x plus 3. Now, the movement is the opposite of substitution that you are doing. You have replaced x by x plus 3. The movement that it causes is the opposite of what you see here, which means 3 left. And you're adding, it causes movement to the left. Same way here, you're adding to y, it causes a movement opposite of this, which means 4 down. You notice x and y, we are treating both of them same way, but the price we pay is that you have to modify your function slightly so that the modifier and the modified are right next to each other. Let me do one more thing, because it's an important and rather confusing issue. And as I said, even we come to trigonometry, this becomes even more challenging. So what's the right place for the 7? Right place for it is right next to y. That is, subtract 7 from both sides. No, that's how it looks like. So x plus 3. Yeah, on the face of it, you're adding 3. What happens is the opposite of what you see, which is you have to go opposite direction of what you're substituting here, which is 3 to left. How about here? Opposite of subtraction is what? Addition. So what are you going to do? It's going to be 7 up, which is what we said here as well. Okay, so try to understand it both ways, and then you'll be much happier later on when we come to trigonometry. Okay, so here's the end of our short lecture on translation. So what happened here is that we had double translation. The way this is different from the previous one, we are changing x and then there is a trailing number. So the function with its parentheses is all done, and then after that we are tagging along a certain other quantity. That one is a modifier of y, so better be moving to the other side. And once you do that, x and y, both of them follow the same rule, and the same regulation apply to both of them. Okay, until next time, good luck and God bless.